In this example, we're going to look at how to write a polynomial function in standard form, even though I didn't write in standard form on the board there, with these given zeros. So we have to know, looking at these zeros, or these roots, if you will, that if we have 4i and 3 as given roots, there's actually one more. The Conjugate Root Theorem, which I discussed in another video, says that any imaginary roots have to occur in conjugate pairs. So if 4i is a root that's been given to you, you must also know that negative 4i is also a zero of this function. So if we want to go ahead and write a polynomial function with these given zeros, first of all, to make it a function, let's go ahead and make sure we include the y equals. If you're asked to write a function and you don't include something like that, you just write an expression, you technically didn't do what you were asked to do. So pay attention to the detail on that. So if these zeros exist, then the linear factors that must have created them must be x minus these zeros. So this one right here must have came from an x minus 4i factor. I'm going to go ahead and put this one with the other I one right next to it. I would have had x minus negative 4i. I'm going to go ahead and clean that up a little bit. Instead of writing minus negative 4i, I'm going to write plus 4i. And then for this zero, its linear factor would have been x minus 3. Again, remember, the linear factors have opposite signs than the roots or the zeros do with that. So here we have this factorization. I know it doesn't say standard form on the board. If it doesn't say standard form in your problem, you're done. I wrote a function with those given zeros. But I'm going to show you how to take this now and put it into the standard form. So we're going to have to go ahead and multiply these two binomials together with the i's. So when we do that, we need to distribute the x to both things in this set of parentheses over here. X times x will make x squared. X times 4i will make plus 4ix, like that. Now distribute the negative 4i to both of these as well. That will make negative 4i times x makes minus 4ix. And negative 4i times positive 4i makes negative 16i squared. Now, I'm going to go ahead and definitely clean that up a little bit. The plus 4ix and the minus 4ix, those two terms will cancel each other out. And then remembering that I squared is actually equal to negative 1. So this basically says negative 16 times negative 1, which is positive 16. And then just bring this factor down as well. Again, if you watched my video on how to factor a sum of squares using the imaginary unit I, you might have been able to go right from here to here if you recognize that. But if you're not familiar with that process, then maybe you need to actually work it out and do all the distributing there. Now, we still need to go ahead and finish this. We're not done. We have more distributing to do. Take this x squared and distribute it to both of these. That will give me x cubed, and then minus 3x squared. And then finally distribute my 16 to both of these. 16 times x is 16x, and 16 times negative 3 is minus 48. So here is my polynomial function in standard form with those given zeros, and also having the awareness that this other zero had to exist because of what the conjugate root theorem told us.